lesson 2. Lesson 2 is just about like ratios and calculating decimals in your calculator. We're going to be doing that stuff anyway throughout, so it just kind of happens naturally. We're going to jump right to lesson 3, where we're going to calculate side lengths of triangles. We're going to start with a little bit of review, and then we're going to learn the new stuff, okay, where the stuff yesterday comes in handy. Review on triangles. The first thing you're going to want to remember is that you can only do this stuff with right-angled triangles. Right? Same thing I said yesterday. This only works if you have a 90 degree, 90 degrees. 90 degrees indicated by this guy right here. Right? You need that somewhere in the triangle for it to be working. If you want to find a missing side length, you guys already have a strategy, and the best strategy you could possibly use is Pythagorean Theorem. You're good at it, right? You've been doing it for a couple of years now. Like, you should be pretty solid with Pythagorean Theorem. This is Pythagorean Theorem right here. I don't like to write it that way. I like to write it like this. A squared plus b squared equals c squared. It's the exact same thing. I just prefer it that way, and that's just how I read it out. So if you hear me saying this, it's the same thing as what the textbook has. Okay? This is the formula I would use if I'm trying to find the hypotenuse. Okay? Yeah. Okay. That's never fun. That formula solves for the hypotenuse because c is by itself. And if you remember from Pythagorean Theorem, c represents the hypotenuse. When you're looking at your right angle triangle, the hypotenuse being the longest side across here, we always call it c. The other two sides, when you use Pythagorean Theorem, you can interchange them. Like, you could call either side a, either side b. The only side that matters is side c. It has to be the hypotenuse. If you want to find one of the other sides, you would just rearrange the Pythagorean Theorem to come out with one of these formulas. You realistically only need one of them because you can just interchange which one's A and B, right? It's the same thing. That should be reviewed. We even did a little bit of Pythagorean Theorem in the first unit. I think it's best if we just kind of jump into a question. We'll do 2 questions on Pythagorean Theorem so you can see how to calculate missing side lengths in a triangle. So I come to this question that says, calculate the length of the third side. I look down here. I notice I have 2 sides given to me. When I have 2 sides given to me, I can use Pythagorean Theorem, so I start labeling my triangles A, B, and C. C has to be the hypotenuse. A and B, doesn't matter which one's which. I'm just going to say A, and B. If you got it backwards, same thing. Fantastic. Now that I've labeled my triangle to use Pythagorean Theorem, I can figure out which formula I want to use by figuring out which side length I'm looking for. I'm looking for side length C. That means I'm going to use c squared equals a squared plus b squared. Just going to give myself a little bit of room here. I'm going to use this formula right here. C squared equals a squared. Oh, I need to put a. Get ahead of myself. So that's the formula I'm going to use because that's the formula that has c by itself. And c is what I'm looking for. To use that formula, I'm going to plug in my other side lengths. Okay? So plug this one in for A, plug this one in for B. So it's going to be c squared equals 2.5 squared, 3.7 squared. I write so slow, or else it does that squeaky thing. Feels like I'm going so slow. Right, so I replaced A with the side length A, I replaced B with the side length B. I then should calculate this portion of it. So I should put that in my calculator. When I put that in my calculator, 2.5 squared plus 3.7 squared, 2.5 squared plus 3.7 squared, I get 19.94. And that's the answer I usually get a lot of. When you're using Pythagorean Theorem, actually for most of your trig questions, you should try to think if your answer makes sense. And by makes sense, I don't mean that your answer should be to scale, but I mean that your answer should fit with the other numbers you're using. So for instance, if you look at this, I have a triangle with 2.5 and 3.7, pretty small numbers. And then all of a sudden I have a hypotenuse of 19.94. That's dramatically bigger, right? And that typically shouldn't happen. It should be a lot closer to that. I mean, it's going to be bigger because it's the hypotenuse, right? It should be the biggest side, but it shouldn't be that much larger. The reason why 19.94 is wrong is because what are we forgetting to do? We're forgetting to square root. Right? Remember, this is c squared. And we don't want c squared. We just want c. So you square root both sides to figure out that the missing side equals 4.47. And I rounded that number. It was 4.465. So I rounded that to 4.67 or 4.47. Pythagorean Theorem. Remember it? Not bad. Awesome. You can only use Pythagorean Theorem when you know two sides, right? That's the key. So if you look at this question over here, it says find the missing side length. The missing side length is this one over here. I have two sides given to me, then I can use Pythagorean Theorem. When you're using Pythagorean Theorem, you label it A, B, C. C has to be the hypotenuse. The hypotenuse in this case is 122. Is that right? A and B don't matter. If you're looking for the hypotenuse, what do you use? C squared equals A plus B squared. If you're not looking for the hypotenuse and you're looking for one of the other sides, you do A squared equals the biggest side, which is C squared, minus the other side, which is B squared. Like that. You look up here, you plug your numbers. C is 122, B is 120. So you should have A squared equals 122 squared minus 120 squared. Again, you calculate that part, right? So calculate this. When you throw that in your calculator, you're probably going to get a decimal, right? You usually do. It's 122 squared. Oh, no, you won't get this one. Minus 120 squared. You get 484. That's 484. Again, if you look, that doesn't make any sense as an answer yet, right? 484 is bigger than the other sides, including bigger than the hypotenuse. So that should be a sign to me that I'm not done. I'm not done because what do I need to do? I need to square root. When I square root that answer, 22, what a nice number. You get A equals 22.
Sorry, it's like when you list that A, B, and C, is it the same as the hypotenuse, like what we did yesterday?
Yes. So the C is the same as the hypotenuse as yesterday, and then A and B are the opposite and adjacent, but it doesn't matter which one's which. So, that's the difference with Pythagorean Theorem. It doesn't matter. So I could have named this one B and this one A, and it wouldn't have mattered. But the hypotenuse has to be C, and the same as the hypotenuse from yesterday. So this is C and it is the hypotenuse. Yeah, it's the same thing. That's the hard part of this is we name our triangles different ways all the time, right? And that's frustrating. Okay, that's Pythagorean Theorem. Feeling decent? Good. Okay. That's technically Math 9. I think even maybe math 8 you did Pythagorean Theorem, so that's technically a review. What we're going to do is figure out how you calculate a side length when you don't have two sides given to you. So for instance, if you look at this question right here, you don't have two sides given to you. You only have one side given to you over here. The other two are both unknown. That is something we haven't encountered before. All right? If you don't have two sides, you have to have an angle given and a side given. So if you look at this question, instead of two sides given, they gave you one side of the triangle and they gave you an angle in the triangle. When you have that situation, so you know a side length and you know an angle, you're going to use Sohcahtoa, the stuff we learned yesterday. Right? They do step-by-step instructions here on how to do it. I don't like, actually I don't mind how they set it up. I just prefer my way. So I'm going to show you how I would tackle this thing. Okay? So my first step, when I realize I'm looking for a side length and I have a side and an angle, is I label my triangle for Sohcahtoa. That means I label hypotenuse, opposite, adjacent. That's my first step. So looking at this triangle, the hypotenuse is across from the 90. This is my hypotenuse. The next side length I have to label is my opposite. Opposite is across from the angle you know, or the one that you're working with. In this case, across from 52 degrees, this is my opposite. Adjacent is always the third side. Awesome. I'm going to have to squeeze this in here somehow. So this should work. So my first step was label my triangles. My second step is to write out Sohcahtoa. So remember Sohcahtoa we learned yesterday, it helps remind us of the trig ratios, sine, cos, and tan. Sohcahtoa looks like this. Here's how I use Sohcahtoa. I use Sohcahtoa as like a checklist. All right, it's going to tell me which ratio I need to use to solve this triangle. And the way it's going to do that is I'm going to give check marks. The first check marks I'm going to give are my free spaces. I'm going to check off S, C, and T. I always check those three off first. Call them my free spaces. Then I'm going to check off the side lengths that I know. So if you look at your triangle, you know your hypotenuse is 14.2. Then I'm going to put a check underneath my H's for hypotenuse, saying, yeah, I know my hypotenuse. The next thing I'm going to put a check mark under is the side length I want to know. I want to know my opposite. So I put a check mark underneath my O. When you're done that process, so you do your free space, you do the side you know and the side you want to know, one of your ratios, one of your Sohcahtoas will have 3 checks. This one has 3 checks. That tells me I need to use the sine ratio to solve this triangle. The sine ratio, if you forgot, sine of an angle equals opposite over hypotenuse. That's what this is telling me. It's saying use this ratio. This symbol might be new to some of you. That's just, I was going to say theta, then all of a sudden I lost all confidence in that. It's a Greek letter. I'm pretty confident in theta. I'm just having that second guessing moment for myself. That means an angle. Okay, so it says sine of an angle equals opposite over hypotenuse. Okay, before we get into the math, we looked at this triangle. We realized we had a side and an angle. That told us use Sohcahtoa. So we labeled our triangle. Hypotenuse, opposite, adjacent. Then we wrote out Sohcahtoa, and we checked off things. We checked off the free spaces, S, C, and T. We checked off the side length we knew, which was hypotenuse. And we checked off the side that we wanted to know, which was the opposite. The check with 3 spaces said use that ratio or that formula. Use the sine formula. Fantastic. Now let's use that formula. So what we're going to do is we're going to replace the 3 things in this formula that we know. That's the angle, that's the opposite, and that's the hypotenuse. We're going to replace it with all the things we know. So to do this question, I'm going to have to just drop it down a little bit. Sine of an angle. The angle you put in there is the angle they gave you, right? The one that you used to name the triangle. So it's now sine 52. I like to put it in brackets like this. That reminds me, it's sine at 52 degrees. The brackets just help remind me that the angle's with sine. Equals my opposite side. My opposite side is x. We don't know it. Right? Whichever one you don't know, you just call x. Divided by your hypotenuse side. Looking at your triangle, your hypotenuse is 14. You just created like a math formula or some sort of equation that you can actually solve because it only has one variable in it. Right? And all that's left is x and then a whole bunch of numbers. You can solve this by isolating x. That means getting x by itself. To get x by itself, we need to get rid of the divide by 14.2. What's the opposite of divide by 14.2? Multiply by 14.2. So I'm going to multiply both sides by 14.2. On this side, it would cancel out. And over here, I would have 14.2 times sine of 52 degrees. This thing can go in your calculator. Alright, so if you have one of these fancy calculators, actually if you have any calculator, before you can use the sine, cos, tangent ratios, you have to tell your calculator to be in a certain mode. It has to be in something called degree mode. Okay, with these calculators, you turn on your calculator, on, and then you click mode, which is up here. Mode's up here. It's going to bring you to a list of things, a whole bunch of menus. The second thing down should say, the third thing down should say radian, and beside it, it should say degree. The word degree needs to be highlighted in black. If it's not, then you go down and then over until you're on it, and then hit enter on the word degree. If you have a different calculator, we're just going to hope you're in degree mode, and if you're not, then I'll look at your calculator and try to help you switch it. Okay, so some of you guys who have different calculators, I'll help you out. We'll just hope it's in degree mode. Usually they are. Awesome. Using different calculators sometimes is a little different when you do this calculation. For us, with these calculators, you can put it in the exact way you see it. So, if you hit second mode, it'll take you back to the main screen. I can just go 14.2 times sine. Sine is right here in the middle of the calculator. SIN. You click sine. You'll notice it brings up sine in a bracket on your calculator. Then you go 52 and close that bracket. 52, close that bracket. If you hit enter, it's 11.1897527. Rounding that, we usually round to the nearest tenth. This question say, we'll just round it to the nearest tenth. So we'll say it was 11.2 equals x. For those of you with different calculators, typically what you need to do is you need to put the degree in first. So you go 52 and then hit sine, and it'll give you a decimal, and then hit multiply by 14.2. I'll come and take a quick peek right there. Awesome. That's Sohcahtoa. So that's what we're going to do all day today. It's how you find a missing side length when you don't have two side lengths given. Remember, if you have two side lengths given, Pythagorean Theorem. Just every time. If you have one side length, one angle, we use Sohcahtoa. And that's my method for using it. It's the same method as here. I just feel it's a little bit more like structured and a little bit more foolproof. So I like to use it that way. Okay, a word problem. So they say a ladder 4.5 meters long just reaches the top of a wall. The angle between the ladder and the ground is 65 degrees. Make a rough sketch and determine the distance between the bottom of the ladder and the bottom of the wall to the nearest tenth of a meter. Okay, you're going to do a lot of word problems in this unit. It's just going to happen. It's trig. When you do these word problems, I have two suggestions for you. Suggestion number one, draw a picture every single time. Suggestion number two, in that picture, there has to be a triangle. Right? This is the trig unit. There's going to be a triangle in every question. It's a guarantee. So in your picture, if you're really struggling, just draw a triangle and start labeling things. Okay? For this one, it's a little bit more foolproof, so we're going to try to draw it. Again, I like to read a question once, read it again, and then start labeling. It says, a ladder, 4.5 meters long, reaches the top of a wall. So, I have a wall. I have a ladder. The ladder touches the top of the wall. That's my ladder. The purple thing is my ladder. Bottom is the ground, side's the wall. You might want to even label it to yourself, be like wall, ground, ladder, so you know. Now that I've kind of got my triangle going and I kind of know where things are, I can start to label it. So it says a ladder 4.5 meters long. And that means my ladder right here is 4.5. A ladder, 4.5 meters long, I've done that, just reaches the top of the wall. I've done that. The angle between the ladder and the ground. All right, that's key. Between ladder and ground. So you need to figure out where the ladder and the ground are touching. The ladder and the ground are touching here. So when they say the angle between the ladder and the ground, that's what they're talking about, where those two things touch. Is 65 degrees. Fantastic. Make a rough sketch and determine, we did a rough sketch, and determine the distance between the bottom of the ladder and the bottom of the wall. Bottom of the ladder, bottom of the wall. They're looking for this distance. When you're looking for something in math or you don't know something in math, we call it x. Fantastic. We drew our picture. It looks gorgeous. We need to try to solve for x. When I look at this and I'm trying to solve for a side length, I ask myself, do I have two side lengths or do I have a side length and an angle? In this case, I have a side length and an angle. That tells me I need to use Sohcahtoa. To do Sohcahtoa, you have to label for Sohcahtoa. So let's label for Sohcahtoa. This is my hypotenuse. It's across from my 90. The wall and the ground would be my 90. Across from the 65 is the opposite. My adjacent is the third side. Now that I've labeled my triangle, I'm going to write out Sohcahtoa. Sohcahtoa is a checklist, right? It allows me to choose the proper ratio. To choose the proper ratio, I put a check mark underneath S, B, and T. Those are my free spaces, like bingo. Then I put a check mark under the side length I already know? Because I already know it. The side length I know the distance of is 4.5. That's my hypotenuse. I put a check mark under hypotenuse. The side length I want to know, I also put a check mark under. The side length I want to know is adjacent. So I put a check mark under adjacent. One of your things should have 3 checks. In this case, it's ca. Ca means cosine of an angle equals adjacent over hypotenuse. Your job now is to fill in the 3 blanks. Fill in the angle, fill in the adjacent, fill in the hypotenuse.
Why is it the adjacent, not the opposite?
Why is it the adjacent? Because I'm using the cosine ratio. And cosine uses ca, which is adjacent. So that's just the formula for cosine.
But don't you already know the adjacent? Like, isn't the adjacent the degree?
Oh, I see what you're saying. No, this would go here. Try to highlight it. The angle goes in this spot.
Oh.
The adjacent is going to be our x, our unknown side length. So the sides are always the outside numbers, and then this guy always be the inside. Yeah, that's a good question. Yeah. Yeah, for sure. You can use mine. You pass me yours. Let's see if I can get it where we want. That's good, eh? Awesome. Now that we have our formula chosen and we've chosen to do cosine, we need to fill in. Doesn't want to like. There we go. We need to fill in our 3 blanks, right? Our angle, our adjacent, and our hypotenuse, based on this triangle. To do that, I go cos. The angle is 65 degrees. It comes from my triangle. For the record, you can't use the 90 degree, right? So every once in a while, somebody tries to put the 90 degree in there, and that won't work. You have to use one of the other corners. Okay, just so you know. Equals the adjacent side is x divided by the hypotenuse side, which is 4.5. Yeah.
Will there be a question where it asks you to use the 90 degree side to find?
No, it won't happen. It breaks. It doesn't know what to do. Once you put your numbers into your formula, you need to isolate for x, so get x by itself. In this case, to get x by itself, you need to move the 4.5 over. This is divide. The opposite of divide is multiply. So I multiply my 4.5 over. It'll cancel on the right side, and I'm left with 4.5 times cos 65 equals x. You need to put that part in your calculator to get the right answer. I'm going to try this calculator. I don't know if it's going to work. Yeah, like won't let you push certain buttons. Hey, I can do sine. Yeah, it's just broken. Still not working? Okay, I'll try again for you. So everybody should be trying to calculate that. See if you can get the right answer. I'm going to see if I can get the right answer too. Times cosine of 65. I got 1.9.
Yeah.
Hey! Not bad for a guy who doesn't know what he's doing. That means the distance from the base of the ladder to the base of the wall is 1.9. That's trig, right? Like that's as hard as it's really going to get when it comes to word problems. They could do a little bit more on that, okay? So they could do multiple parts to it. So they could say, what's the distance from the bottom of the wall to the bottom of the ladder? Then they could say, part 2 of the question, okay, how tall is the wall? Right? And now you actually have 2 choices to solve that. So if I said, how tall is the wall? Well, I could say, well, this is 1.9. That means I have 2 side lengths. I can use Pythagorean Theorem now. Or I could still use Sohcahtoa. Right? Sohcahtoa would just be, now I'm finding the opposite and I have the hypotenuse. Both would give you the same answer. So the next example actually does exactly that. It says, determine the height of the wall using trigonometric ratios using the Pythagorean Theorem. And it's going to be the same answer for both, hopefully. It might differ a little bit, and if it does, we'll talk about that. It'll be a good learning point. So let's try to determine the height of the wall using a trig ratio. That means using Sohcahtoa. All right, first step, label your triangle. We've already done that. Opposite, adjacent, hypotenuse. We're going to pretend that we don't know the adjacent. All right, we're going to use the info that they gave us rather than the info we calculated. The reason why I think that's a smart move, if we screwed up calculating the adjacent and then we use that answer to calculate something else, we're going to screw up twice, right? And our screw up's just going to keep happening down the line. If I only use numbers they gave me, then I know I'm right. Okay, so I'm going to pretend I don't even know the adjacent still. I want you to try to choose the right ratio. Okay, so it's on you. Write out Sohcahtoa. See if you can choose the right ratio. So you're using it as a checklist right now. So when you looked up at your formula, you should have put a check mark under S, C, and T. Right? Those are the freebies. Then you put a check mark under the side you know, which is H. Then you put a check mark under the side you want to know. Now you're looking for the wall. That's the opposite. That means sine should have been the ratio you used. This tells me my formula. Sine equals opposite over hypotenuse. So I need to use this formula. Fantastic. Now that we've chosen the right ratio, try to solve it. Okay, so see if you can plug in the numbers and see if you can get x by itself. So give it a shot. Using the triangle above, all on you. I've already filled out the answer up here on the board. The first step is to put numbers in, right? For the angle, I'm putting 65. For the opposite, I didn't know it, so I put x. And for the hypotenuse, I put 4.5. That gave me the blue equation right here. I then had to get x by itself, which is how I always prefer it. So to get x by itself, I had to move the 4.5 to the other side. To move the 4.5, I had to multiply 4.5 to the other side. That cancels out on the right side, that's why there's a red line through it. And I'm left with 4.5 times sine of 65. I wrote underneath it, calculate that. You just throw that in your calculator. If you're not getting the right answer, there's a good chance you're in degree mode or just pushing the wrong button, right? Sorry, radian mode, not degree mode. Just tell me, right? I can help you with the calculator part. If you can do all the algebra, don't let not asking for help stuff get you stuck. Okay. The answer would have been 4.078. You should round that to the nearest first decimal place. 4.07. 7 rounds the 0 up to 1. Right? So 4.1 would be my answer. If you did Pythagorean Theorem, you're not gonna feel like it's not the best use of our time. You would get the same answer. Okay, so technically you could use Pythagorean Theorem with the old answer of 1.9 along the ground. And then you would get the same answer. My only recommendation is if you do that, don't use 1.9, use the entire digit we found. Right? It wasn't just 1.9, it was like 1.8 something, 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 something. Use that. Right? Use the full number. If you round and then you round again, there's a good chance that you double round and it messes you up just this much. Awesome. The only way this stuff gets harder is if what you're looking for isn't on the top of your ratio. Okay, so for instance, we got a question here. It says find the missing side length or find side length A. So if you notice, we only have one angle and one side. That means we need to do Sohcahtoa. I'm going to label this thing for Sohcahtoa. This is my hypotenuse. This is my opposite. This is my adjacent. We then write out Sohcahtoa to choose which one we want to use. When we write out Sohcahtoa, we find out that we need to use, I'm just trying to find out a good spot to write this. Sohcahtoa. We put a check mark underneath our freebies, underneath our adjacent, and underneath our hypotenuse. We need to use chi. Here's the difference with this question. When we set up cosine and we put in our numbers, okay, so we're going to have cos of 64 equals, and then we're going to have adjacent, which is 7.9, over hypotenuse, which they've called A in this case. We get a little bit of a problem. The problem that we get is that the variable isn't on the top of the fraction anymore. Before, it used to be really easy. We would just look at it and say, oh, multiply the bottom number over and you're good. This one's trickier. The reason it's trickier is because you can't just divide 7.9. And that's what people want to do. Dividing 7.9 would leave you with an invisible 1 divided by A. It doesn't leave you with A. It leaves you with 1 over A. Right? That's a problem for us. So the only thing that makes this a little trickier is the math. I'll show you the math of why it works, then I'll tell you a trick in case you're like, that did not work. All right? The math. You have to get A off the bottom of the fraction. The only way you can get A off the bottom of the fraction is to multiply it to the other side. Like that. When you multiply A to the other side, it'll cancel out on this side. And you'll be left with A equals cos 64, sorry, A times cos 64 equals 7.9. So that got A off the bottom for me. Now I can try to get A by itself. To get A by itself, I'm going to have to move cos to the other side. The opposite of multiplication would be division. So I divide cos to the other side. That will cancel on this side, and I'll be left with A equals 7.9 over cos of 64. That's the math behind it. Okay, so I moved my variable off the bottom of the fraction, then I isolated the variable. The trick. If you're like, oh, that math was like, oh, nope, I didn't get it. The trick is putting it in your calculator. Okay? If what you're looking for is on the top, you're going to multiply. So you'll do the number times sine, cos, or tan. If what you're looking for is on the bottom, like here, see how A ended up on the bottom? You're going to do the number and then divided by cosine or tan. But always put the number in your calculator first, the side length, and then choose divide or multiply. And it'll always work out for you. Okay, so letters on the top, I hit multiply. Letters on the bottom, I hit divide. It'll just take some practice and you'll get good at it. This can go in your calculator, this part. So you go 7.9 divided by cos of 64, 7.9 divided by cos 64. We get 18.02, it rounds to nearest 10th, 18.0. That's the only way it gets harder. Only way it gets trickier. Like they'll throw word problems in and stuff like that, but the actual math behind it, that's the trickiest math gets, is that double swap. And realistically, you can just remember the divide by, multiply by trick, and you'll be fine. for sure. Wicked. Let's see how this works, but with a little bit of a word problem. So this question said, I think we have two. We have two questions here, we'll do. This one says, determine to one decimal place the length of the hypotenuse of triangle PQR, in which angle PQR equals 90 degrees, angle PRQ equals 28 degrees, and PQ equals 15.6 degrees. All right. They gave you no info there, right? Like, at least it didn't feel like they gave you any info there, right? They just gave you a bunch of math. Let's start off with this. Triangle PQR. Okay, they gave us a triangle. Let's draw that triangle. When they say PQR, that means that's the three corners, okay? P, Q, and R. Where we put those letters does matter. And it matters based off of this right here. And this right here. How to read this? Yeah, it is the corner. Yeah. So when you're reading angle and they give you three letters, the middle letter is your angle. So they're saying Q is 90 degrees. Looking at this, that's my corner or my 90 degrees. This has to be Q. The other two sides don't matter now. You could call them P or R and then just label properly. So you say P, R. Awesome. So the middle letter tells you that's the angle they're talking about. They're talking about angle Q. This one right here, that means they're telling you what? Angle R is 28. Looking down here, that means this is 28. And PQ, that means the distance from P to Q, P to Q, is 15.6. So we took all that math language, we turned it into a triangle where we've labeled it all out beautifully. Now we have to figure out what they want us to calculate. It's set up here, determine to one decimal place the length of the hypotenuse. The length of the hypotenuse would be this side. So I call it X. When I don't know what it is, I call it X. Fantastic. I'm going to let you try to solve that one on your own. Okay, so give it a shot. You have to write out Sohcahtoa, choose the right ratio. Once you've chosen the right ratio, you need to try to do the math. Right? Give it a full-on shot. I'll do it up on the board while you work. Okay, so I've done my work up here on the board. I've tried to color code it. I always try to do that to try to help. I sometimes don't know if it helps or it hurts. If it's in blue, it came from my formula. Okay? If it's in red, that was me moving things around. And if it's purple, that was me canceling things out. All right, so I wrote out Sohcahtoa. After I labeled my triangle, opposite adjacent hypotenuse, right? Make sure your labeling is the same as mine. So opposite is across from 28, hypotenuse is across from the 90, adjacent is the third side. I do my little check marks. I put a free check under S, C, and T. I then put a check mark underneath O and a check mark underneath H, right? Because it's what I know and what I want to know. I'm left with sine equals opposite over hypotenuse because it had 3 check marks. Once it has 3 check marks, I write out the formula and I replace my 3 things with the variables or numbers that I know. I replace the angle with the angle 28. I replace my opposite with my opposite of 15.6. And I replace my hypotenuse with my missing side, which is x. And I'm left with this blue thing. Sine 28 equals 15.6 divided by x. Now the math behind it is to get the x off the bottom and then divide by sine to get x by itself. The way you could just do the trick is x is on the bottom, means I do 15.6 divided by sine, right? If what I'm looking for is on the bottom, I go number divided by sine. If x was on the top, I would have gone number times whatever it was. Either way, you need to try to put this in your calculator right here. When you do put that in your calculator, you should have got 33.2288497. You want to round to the nearest first decimal place. 33.22 would round to 33.2. That'd be my answer. Fantastic. I think we're feeling good with trig.
Would you need to add the measurements?
That's a good question. Measurements. I'm not picky at all about measurements, or in what it means is, what's the term I'm looking for? This thing. That's what you're talking about. What's it called?
Millimeters?
Yeah, that's millimeters. But you would call that a unit. Thank you. That's the word I'm looking for, you science people. I could care less about units. So on any question, if it talks about kilometers, meters, centimeters, whatever, I'm indifferent. So reality is, if you just have the right answer, I'm happy. If you forget to put kilometers per hour, I can care less. I'm marking this, the math and that. Now, realistically, you should know, right? It's probably good for you to know, but I'm not that picky about it. All right, before